About rationalizing the denominator of my radical expression. When they tell you to rationalize the denominator, what they're really telling you is to get the square root out of the bottom of the fraction. In best form, you never want to have the square root in the denominator. And so there's a few things you can do. One thing is you could just multiply by itself, but if you have a big number there, you probably don't want to have to take the square root of 35 times the square root of 35 because it's going to be really huge. So you can look at it to see if they're both under square roots, can I reduce it? Now if one's not under the square root and the other one is, I can't reduce it. But if they're both under square roots, like on the previous problem, I can reduce. So in this case, I can divide both of these by 7 and make that the square root of 3 over the square root of 5. And now my numbers aren't so big. Now I'm going to rationalize the denominator by multiplying by what's in the denominator. And of course, I'm making an equivalent fraction, so technically I'm multiplying both the top and the bottom by whatever's in the bottom. On the top then, I'm going to have the square root of 15. On the bottom, I'm going to have the square root of 25, which should be a perfect square because I took 5 times 5, right? I can then simplify the bottom, and I'm going to have the square root of 15 over just a plain old 5. Again, I would want to think about, can I simplify the square root of 15? In this case, I can't because 15 doesn't have any factors that are perfect squares other than 1. And so if you would have something like 32, then those were the ones we were simplifying the other day, and we'd try to simplify it farther. But in this case, I can't. And again, I can't reduce that down because one's under the square root and the other one is not, so I can't do any reducing with that. Number 8, I want to rationalize the denominator and simplify. In this case, I have the square root of 6 over the square root of 11. I can't do any reducing, so I just want to rationalize the denominator by doing what?
Taking them both by the square root of 11.
Taking them both times the square root of 11. So I'm going to get the square root of 66 over the square root of 121. And square root of 121 should now be a perfect square. The square root of 121 is 11, right? We took 11 times 11 to get 121, so the square root of 121 is just an 11. No longer has the square root sign over the top of it, so it's rationalized. Again, you would think of 66 to see, can I simplify the square root of 66? But I would have like 2 and 33, none of those are perfect squares. 6 and 11, those aren't perfect squares. So there aren't any factors that I can factor that into so I can simplify that any further. And number 9, same kind of thing there. I want to rationalize the denominator. So even if I could have reduced these, I can't because one's not under the square root and the other one is. So I'm just going to go ahead and rationalize my denominator by doing what?
Timesing it by 2?
Timesing it by the square root of 2. Square root of 2. And in this case, when I take 11 times the square root of 2, one is not under the square root and the other one is. It's like when you take an 11 times an x, you just put the number in front of the square root. So you write it as 11 square root of 2. That means 11 times the square root of 2. On the bottom, you're going to get the square root of 4, but you can simplify the square root of 4 into 2. So I'm going to get 11 square root of 2 over 2. Now in this case, if I could do these two numbers without the square roots and reduce them, I could do that. But I can't take 11 divided by 2 and reduce it at all. So that is in simplified form. If it was 10, I could reduce, but in this case I can't. So either if they're both under the square root you can reduce, or if they're both not under the square root you can reduce.